Und wir sind live.
We're live. Awesome. Yeah, so I'm just gonna go ahead and start. I think we already have a few people here. Welcome to KarlsruheJS Worldwide. I'm keeping it English since we're worldwide. Yeah, so this is the first time in a long time that we have a KarlsruheJS event, and I'm gonna say a few introductory words here. So first of all, the team. Who's the team? The team is Martina, Eugene, and me, Khalil. Martina is, I think, a freelance developer at the moment, specializing on WebAssembly and Angular. Eugene is a digital nomad, or at least he was, is currently working with a startup in Baden-Württemberg somewhere. And I'm an engineering manager for a company known as GoTo. You see it here. And yeah, and we've been organizing KarlsruheJS since quite a while. Because of the pandemic, obviously, there were no in-person events since 2020. So a few words about KarlsruheJS. KarlsruheJS is the local JavaScript meetup event, recurring event that has been happening locally in Karlsruhe at different companies for a few years already. And since 2020, obviously, has moved online or remote, so to speak, like everything else. All the work kind of moved online. And yeah, but since it wasn't super interesting there were a lot of online events, and we didn't really have the same feel, and there was not the same kind of interest in having these events anymore, and people also got a little busy. But since there was a little bit more demand again, and I think we didn't have this event in such a long time, it was really good to do this again. And Martina kind of gave us the push to do it. She's also responsible for most of the organization, speakers, everything. So thank you very much, Martina, for all your hard work. And yeah, that brings me to our contact. So if you are interested in contacting us, if you want to give us, if you want to give a talk at KarlsruheJS, because we're going to keep doing these events going forward. And obviously, you know, if things loosen up a little bit, they will go back in person as well, maybe with in person and streaming. Who knows if we can level this up. But if you are interested in giving a talk or just interested in helping us in some way, you can do that by contacting us on Twitter at KarlsruheJS, or write us to mail@karlsruhejs.org. And I just wanted to give a little bit of a pitch for anybody who's maybe on the fence about speaking. I think these kind of JavaScript meetups, be it KarlsruheJS or other meetups, are really a great kind of entry point for people who haven't been giving talks but maybe want to give a talk. I think it's a really good addition to your resume, or you can add it to your website after it's been posted online and stuff like that. And it also makes it easier for you to get into conferences if you want to give a talk at a bigger conference. And it's a great way to publicly declare yourself as an expert in a field, or somebody who is interested in something specifically. And so, yeah, we love to see people out of our community to speak, to come and speak out of our community. We had a few really notable people who gave their first talks at KarlsruheJS, which makes us really proud. And we love to see that. We also had people just out of the JavaScript community in general, you know, from through our network on Twitter and stuff like that. But it's always awesome to see people from the KarlsruheJS community coming to us and who want to speak. And we're also always happy to help with anything along the way. You know, constructing the talk, doing like a dry run, all this kind of stuff. So yeah, so those just as maybe a motivation for people to come and reach out if you are inclined. The schedule today, we have, obviously, the intro is what you're currently listening to or watching. And our first talk will be with Christian Liebel about Fugu and progressive web applications. Then we'll have a 10-minute kind of Q&A session with Christian, then a short break. You can get yourself a drink, go to the bathroom and so forth, maybe hang out in the chat. And then we have Rainer talking to us about WebAssembly. And yeah, and then there's a Q&A with Rainer, and after that, open-ended kind of hangout in the chat and so forth. For asking questions, please use the chat on YouTube. Supposedly you're watching it there, so that's going to be our chat for today. We also have a Discord chat, but I don't think we'll be hanging out there today. Yeah, and so without further ado, I would like to call Christian Liebel onto the stage. Please give us a little bit of an emoji applause for Christian, and let's hear it about PWAs and Fugu. Thank you.
All right. Thanks, Khalil. And hi, everyone. Yeah, the first talk is about Project Fugu and PWAs. And the second one, by the way, is about Rust and WebAssembly. And I think both topics are super interesting for JavaScript developers because, at least from my perspective, they are the next level for JavaScript and for web applications in general. All right, so let me bring up my slides so we can start. Okay. Cool. So, Project Fugu. That's a code name, by the way, and we will see in a second for what it stands or what the meaning is. And what it does is it superpowers your progressive web apps. Now, let's see how it does that. Now, first of all, I'm not sure if you've heard about progressive web apps yet. That's a web-based application model, originally invented by Google several years ago. I think it was 2014 or 2015, depending on what you count exactly. But PWAs are around for quite a while. Now, as for many web technologies, PWAs is not the exact standard. It's like for web components where there's no web component specification. Instead, PWAs are a set of specifications that web applications can implement. For PWA, that's the web app manifest, which defines the appearance and the behavior of the installed web application on your system. And there's the service worker, which allows you to hold an offline copy of your application on the user's device. And combining those two technologies allows you to install a web application on the user's system, so they can use it even if they are offline. As I've said, PWAs are around for quite a while now, so it's not really a new technology. However, there were still some missing bits and pieces, at least until now. Let's compare what PWAs can do and what they maybe cannot do today, which they could do maybe tomorrow. PWAs are, as I've said, offline capable. With the help of the service worker, you can install these applications to your system. On all operating systems except iOS and iPadOS, they can receive push notifications as native applications can, and that may change, by the way, with the release of iOS 16. There have been, at least the push API appeared in the beta versions of iOS 16, so let's see. And for example, they had webcam and microphone access. So right now, I'm using this web-based client here to talk to you, which shows that we can perfectly use a browser to implement powerful applications like the one that we are currently using to bring you this stream to your home. However, there are also some capabilities that PWAs do not support, and again, at least until now. One of those could be file system access. Your users may be used to opening a file from the local file system, change it, and then saving it back to the original file, essentially overwriting the original file. Maybe you also want to access the clipboard of your operating system to exchange data with other built-in applications on your system. And finally, what we didn't have until now was access to the local fonts table. That means to the list of installed fonts on your system. And now, as I've said, this is about to change, or it has already changed, thanks to Project Fugu. Project Fugu is a code name, and it's a code name by the Chromium contributors. It's a sub project, so to say, of the Chromium project. Officially, it's called Web Capabilities Project, but actually nobody calls it using that name, but instead Project Fugu is a name that is rather well known. And this code name also means something or wants to tell us something. Let me go back to the previous slide. Giving web applications or web pages access to your file system or to your local fonts table is a problem, because there could be malicious sites that try to write data to your local hard drive, maybe overwriting system files. And of course, getting the list of the installed font names is a problem for privacy of users. Because if you have installed corporate fonts, for example, I can tell if you are an employee of a certain company, or at least it's relatively sure that you are an employee of a certain company. And evaluating the list of installed fonts is actually a pretty accurate fingerprinting vector, especially combining it with other pieces of information that we have. But as you can also see on this slide, there's a need for web applications and websites to access these capabilities. For example, if we want to build an image editor or video editor, I don't know, an Excel or word processing application, so Office-style applications in the browser, then we need those interfaces. And this is what the Fugu here wants to demonstrate or to tell us. Fugu is a quite famous dish in Japan. And it's very special because it makes your tongue feel a little bit dizzy if you eat the flesh of the fugu. And that is because the fugu is poisonous. So if prepared correctly, everything's fine and it has this very special taste. If not prepared correctly, it is a problem, at least. And this perfectly demonstrates those new Fugu APIs. So yes, if done in the wrong way, they could be hazardous. But if done in the right way, it's good. And that's what the Fugu team tries to do. And tries to solve security and privacy-related problems. Going back to the previous slide, for example, it's not possible to just arbitrarily open a certain file or pasting something. Pasting something from the clipboard. That's not just super ready and perfectly accessible. There are some special requirements that you need to fulfill to be able to access those interfaces. Project Fugu is a joint effort, as I've said. It's part of the Chromium project, and it is a cross-vendor initiative led by, but not limited to, Google, Intel, and Microsoft. Well, Google shouldn't be too much of a surprise because they have Chrome OS, for example, which is a web-based desktop operating system, and PWAs are pretty much their built-in application model. Intel is, I think, always a little bit interesting because, well, we know the others and they have operating systems, but Intel actually builds CPUs. So what are they doing here? There's also a pretty good reason for that. Intel has noticed in their metrics that the browser is the #1 application running on their processors. And of course, Intel wants to make the #1 application as capable and as powerful as possible. And then there's Microsoft, and Microsoft has ever been very cooperative to web application developers. With Windows 8, you could implement Windows 8 applications on the exact same level. There was no difference if you would write them with C# or C or HTML5 and JavaScript. Again, there are also more contributors. There's not more than those 3. And the common goal is to bring the web back API by API that is currently missing on the web platform in order to keep the web competitive as a platform. Now, as a demonstration, I've done the following. I've re-implemented this very well-known application called Microsoft Paint in the version for Windows 95. You need to know that I'm a child of the 90s, and so basically this was my daily, most used application back then. I used it to draw tons of images. Now, this application is implemented as a PWA, and that means that it's offline capable and it's installable. And you can use it, as it's web-based, on any device, also any device that you have in front of you right now. If you want, you can open a new tab in your browser, but don't close this one. Open your smartphone, open the browser on your smartphone, and just enter this URL. I will also show the application right now, and then we can see what it means. Writing web-based applications, then implementing them as a PWA, and finally, what Project Fugu now does to give superpowers to this application. All right. Now, first of all, as for all web applications, it's super easy to open them. All you need to do is enter that URL. And again, that was https paint.js.org. Here it is. And this is, again, a web application. And that means that it runs perfectly right in your browser. You can do everything that you expect. So, for example, use the fill tool here and then draw something. This is, by the way, what I did as a child. Always start with a sun here and maybe add some birds over here. That's perfectly possible. It uses the Canvas API, something that's supported for, I think, over 10 years now. So really nothing special or nothing surprising. As you can also see, not all tools are implemented yet. This is entirely open source. And if you want to support me and implement maybe the magnifier tool, then feel free to click the help and then about menu item. There's the repository is linked there, and I would really appreciate that. That's the first level, writing a web application. And again, that perfectly works on all of the devices that you have with you right now. So that means desktop systems with Windows, macOS, and Linux, and mobile systems, iOS and Android, plus everything that allows you to run a browser in one way or the other. Okay, now let's come to the next level. And the next level is PWA. With the help of PWA, or with the help of the PWA specifications, that is the service worker and the web app manifest, the application can now leave the browser tab. And what that means is the following. In the address bar, you can click this little install icon. And by the way, you see that little install icon on more and more websites right now. For example, it's also present on YouTube. And I've stumbled upon it on quite a few sites, especially in the recent months. And then you can choose to install this application. Now, install is a little bit misleading because what it actually only means is that you get a link in the programs list of your operating system. The offline capability is already working. That's what the service worker is already doing. That's why you actually see that install button in the first place. But if you now click that install button, the application will now leave the browser. Unfortunately, it has opened on my other window, but here you can see it. The application that used to run as a tab in Chrome here now runs as a standalone application. And you can see that in the title bar, for example, that now reads Paint. And you can see it in the dock, for example, that now says also Paint. And we can bring up the app switcher, which shows the Paint application on the same level as all other native applications that I currently have open here on my machine. Also, these applications start super fast. Now, let me pin the Paint application to my often used programs and close the application. We don't want to save it. And now watch what happens when I click the application. Boom, it's instantly there. There are no waiting times, there's no loading indicator. The application is entirely loaded from a local cache. And that means it's instantly there, no waiting times whatsoever. Let's watch that again. And boom, instantly there, instantly loaded. That's the second step. Progressive web apps. You can now install these applications to your system, also on mobile devices again, Android and iOS, perfectly possible. There you need to use the 3 dots menu or the share menu on mobile operating systems. You can add it to your home screen, and it also runs in standalone mode then. This means no more browser Chrome, and you have the entire screen real estate. All right, and now let's come to the next level, and this is where Project Fugu comes in. Project Fugu wants to give us access to additional interfaces on the system. For example, file system access, clipboard access, and access to the local font table. Now, let's see how that works. Again, I need to draw something here, so I will bring back this neat drawing from before. Boop, boop, boop. Perfect, great. And let's use another brush. Okay, there's our neat little drawing again. And now what you can do is to save this image now using the file and then save operation. And then the native file picker will come up. This is the native file picker provided by macOS. And here you can, for example, specify the title of the document. I predefined Untitled as a standard name. And now we can call it drawing, for example. I will also bring up my Finder window here so you can see what happens. So if I click Save here, now the drawing appears here in the Finder window. I can also open it so you can see that it's the same thing. And you can see that's my drawing that I just created. Just a little side note, Paint by default uses the screen resolution as a default canvas size. That's why this image is so huge. All right. Now that's also not too spectacular because you could also do that before with the help of the download attribute on the anchor, on an anchor tag, on an anchor element. That would have sent this drawing to your downloads folder. But the cool thing is that you can now also overwrite drawings, and that is something new enabled by the File System Access API. Now, let's say we want to add a third bird here, and now we hit Save again. Now, this file here was overwritten, and that is something new provided by the File System Access API. You can now overwrite files. The File System API even allows us more than that. For example, it allows us to also get access to a folder and create new documents there, delete existing files, and so on. And again, in that case, we see the Fugu because showing or presenting this file picker that we've just seen is an implicit way of giving permission that this is fine to do. So in many Fugu APIs, you will either see a permission prompt, an explicit one, or you will have an implicit permission like that, like the one that we can see here. If the user clicks cancel, nothing will happen. The browser will restrict access. But if it's fine for the user to save that image, then it will just go through. And of course, there are even more security measures in place. Of course, you need to deliver your application via HTTPS. If you're only using HTTP, it will not work. And this dialog can only be shown as a part of a user gesture. So that means a click or a key press. And it can only be executed from the top level browsing context, so not within an iframe. And that essentially rules out those malicious use cases like a malicious ad in an iframe tries to save something that is simply not possible to do. All right, now that is file system access, for instance. But there's more to it. Now, let's say we want to copy one of those birds to another application to, I don't know, further beautify this bird. So I can use the select tool here and select edit copy from the edit menu. And now this selection was written to my clipboard. And I can show you that by opening the preview app, which is the default editing app on macOS. And here I can create a new document from the clipboard. Now if I click that, sorry, opened on the wrong window again, on the wrong screen again, you can now here see my selection that I did here in the Paint application. Also, I zoomed in the Paint app. That's why it's different sizes. But if I would reset the zoom to 100%, it would be the exact same size. And it is also not just working that direction, it also works in the opposite direction. So let's say I want to modify this drawing here by adding another word to it, and then selecting everything and choosing the copy command here. I can now paste it back to Paint. But this time, I see a permission prompt here. And that is the Fugu again. The async clipboard API that is in place here does not allow you to paste contents from the clipboard by default. That is because your clipboard may contain privacy-related data, like passwords or, I don't know, account data that you have in the clipboard. So at least for the first time when an application wants read access to the clipboard, you need to give permission to that application. In Chromium-based browsers, this permission will be stored. So for the first time, if for the first time you clicked allow there, the application will keep this permission. So subsequently, you can simply hit paste and it will work. In iOS, for example, the browser will bring up a permission fly out every time. So here we can click allow, and now we receive back the amended drawing from the preview app here in my browser. All right, so clipboard access does also work. Now we have this text tool here. And what Paint usually does is it shows you the list of installed fonts on your operating system. So let's use the text tool and click the font box. Now, upon click, the application checks if the local font access API is present on the browser, which it is here. And again, we see that permission prompt, and the browser asks if it's fine to give the web application access to the list of installed fonts on my system. And if I click allow and open the font box again, I can now get the entire list of installed fonts on my operating system. And I can now just pick any font from that list. So let's use Avenir, for example, or however they're spelled, and see that it works. Great. Maybe switch the font to, I don't know, American typewriter, and you can see that it works. So another platform-specific API that we now have access to. And that's still not it. Let's say I love to use Paint now, and again, gets the go-to application for drawings. And also let me save that image. And I want to use it to edit all of my PNG files. Then that is also perfectly possible. When I installed this application, the application registered itself as a file handler for PNG files. So if we close this application, that's a bug, by the way, because I've saved it. I don't know why it appears. I have to confirm it again. Again, pull requests appreciated. And if you now right-click the PNG file here, I can now find the Paint application in the list of compatible installed programs. So if I click the Paint application here, you can see that the icon starts to jump, and we again see a permission prompt. Again, at least for the first time when you open a PWA that was assigned as a file handler, this dialog will show up. And it tells you that Google Chrome is trying to open the Paint app, and Paint wants to open this file. And I can now click this checkbox here so that the browser doesn't ask me again when I open PNG files. And then when you click allow, the application will open with the selected file. And because it looks a little bit nicer without that permission prompt, let's try it again. Paint there it opens, and there it is with the file that I selected. Perfect. So all of that seems to work. So what Project Fugu does is it extends the capabilities of PWAs by giving PWAs access to more and more capabilities and APIs that have not yet been present on the web. And again, some of those APIs are newer. For example, local font access API is currently not shipped. It's behind a flag. But the file system access API has been around for 2.5 years now. So that is really ready to use. And for example, the APIs that I've shown you here really help you to implement productivity applications like Paint or Photoshop or IDEs like VS Code, Office style applications, and so on and so forth. But that's not it. There's even more to it. And I want to show you the list of Fugu APIs that are currently planned, that are currently implemented. Therefore, you can go to the Fugu API tracker, and that is fugu-tracker.web.app. When you open this website, you can see the list of interfaces that have been shipped as a part of Project Fugu already, or are planned to be shipped in one of the next releases. As you can see here, we see the current version list, right? So Chromium 99 was released 2 days ago. Chromium 100 is the next big step, right? With potential user agent problems and so on. Let's see what that will bring. Yeah, in the shipped section, you can see the Fugu APIs that have already been shipped that are generally available. And what you can see here is the list of APIs, when they have been shipped, in which version of Chrome. That M56 means it was shipped in Chromium 56. That means Chrome 56 and all other browsers that are based on the Chromium engine. Well, Edge was not Chromium based back then, but Samsung Internet, for example, or Brave could also include this API. By the way, the browser vendors can decide which APIs they enable or not. All right, and here we see, for example, the Web Bluetooth API that gives you access to Bluetooth devices, at least for the generic attribute profile. The Web USB API to talk to USB devices. Web Share Target to register your web application as a share target for other applications. The Async Clipboard API we've just seen for reading and writing images. There's periodic background sync. Badging API, which a Twitter PWA, for example, uses to show a badge on the application's icon. File system access we've just seen. Also, if you click an entry here, you can see a little bit more details about that, and you can see on which operating systems this API is supported. Apple, by the way, means macOS, because Chrome on iOS, as you know, it just uses the WebKit renderer under the hood, so there's no standalone version of Chrome on iOS. And some interfaces don't make sense on certain platforms. For example, file system access does not make sense on Android because this file metaphor is not really the way to go on mobile operating systems. You rather work with intents, for example, or the photo library, but rather not with directories and files. All right, and there's even more and more and more. For example, the next upcoming APIs are the ones behind the developer trial. Today, I've shown you the file handling API. That is for registering a PWA for certain file extensions. And I've shown you the local font access API. And as you can see, there's plenty of more APIs that are about to come. Interesting is the multi-screen window placement API that allows you to enumerate the connected screens and to place your application on a specific screen at a specific position. And that's great for dashboard style situation room setups where you have many screens where you want to place your applications on. But also interesting for presentation apps like PowerPoint, for example. And then there's the ones the APIs which developments have been started. And here, interesting is the raw sockets API. And that's really cool because raw sockets API allows you to access arbitrary ports. Now, not only HTTP, WebRTC, WebSockets, and so on, but any port. For example, I don't know, the SMTP port. And this would allow you to build Outlook on the web, for example, which then creates an SMTP connection and retrieve emails, storing them within the browser, and so on. That's the next very interesting API, which I'm really thrilled about, and I can't wait to try out this API. So that's also another very cool API here. And then you can see the very long list of APIs under consideration. So as you can see, there will still be lots to talk about in the future, thanks to Project Fugu. Now, if you've implemented or if you've worked with cross-platform technologies before, you may know that, or you may use if-def statements, for example, to say, if I'm on Windows, I want to do this, and if I'm on macOS, I want to do that. And as it's the web, this is not the way how it's implemented there. It's much better. All you need to do is call a method. For example, navigator.share. This method, which is also implemented in the demo, if you click the File Send menu entry, allows you to share an image or text or URL with another application that has registered for being a share target on the platform. Now, the browser knows for which operating system it was compiled. So during compile time, that call of navigator.share is connected with the actual platform-specific call. So, for example, calling navigator.share on Android automatically calls the share intent. And calling navigator.share on Windows calls the Data Transfer Manager API provided by the operating system. So instead of doing if dev or if Windows then, if Linux then, all you do is call this method, or to be more precise, test if the method is available. Because the WebShare API, for example, is only available in Safari and in Chrome and Edge and Brave and Samsung Internet and Opera and whatnot is based on Chromium. But it's not implemented in Firefox. So what you should do is to test if this particular method is actually available before calling it. Because as you know, calling a method that does not exist, will lead to an error. So you should first test for the availability of a method and then access it. And if it's not there, you should use a fallback functionality, which typically do exist on the web, depending on the use case, of course. And that this is not just let's say, academic approach here, but is actually being used. I have a little demo for you, which is here. So, for example, there's a new web-based version of Photoshop, which and this brings us to the next topic or to the next talk then, is, for example, also based on WebAssembly. Because here Adobe has taken C code, existing legacy C code, and ported it to the web. And now you can manipulate this image here using ported C code from the traditional applications. And yes, this is not yet super powerful, so it doesn't use the exact or it does not offer all functionality from the desktop version of Photoshop, but there's still lots of stuff that you can do. So for annotating stuff or for trying out things, this is absolutely sufficient. That's one example. And also some of the Fugu APIs that have been shipped in the recent time were actually needed by Photoshop to be implemented as a PWA and in the browser. And you may also use Visual Studio Code on your system. And the cool thing is that Visual Studio Code has ever been a web-based application. So what Microsoft was able to do was just use the source files, use the file system access API, and connect those two with each other. And now VS Code perfectly runs right in your browser. You can install it, you know the principle now, and it allows you to do really, really, really much. You can open folders and create images and so on, create files and so on. You can even use plugins, at least as long as they're JavaScript based. What you cannot do, however, is, for example, open the terminal, because there's no terminal API, and I guess we'll never see that because that's difficult to do, and that's difficult to make really secure and privacy preserving, of course. But everything else just works right in the web. And I think that's super cool. All right, now for a few closing words. What does Project Fugu mean for us as JavaScript developers? Personally, I believe that in the future we will see more and more PWAs. Now, VS Code has already made the beginning here, right, and has made the transition to the web. Not everything works, but at least most of it, and there's a fallback solution if you don't have a terminal, because you can use a cloud-based one, as Visual Studio Code Spaces shows. And I think, and I'm pretty sure that we will also see improved web versions of Office applications like PowerPoint in the future. Already today, we have very, very powerful Office-style applications, Google Docs and Microsoft Office Online. And with the help of these new APIs, these applications should get even better in the future. So, as you can see, I think there's a bright future for PWAs thanks to Project Fugu. So I want to end with a shout out that is, let's make the web a more capable platform and implement great applications. All right, so far everything from my side. I'd like to thank you, and I'm open for your questions now.
Yeah, thank you so much, Christian. That was actually quite interesting. There are actually a couple of questions, and I'd like to start with one of my own. You said in the beginning that Project Fugu was had the vision or wants to make the web as a platform more capable or more popular for software developers. So the first question that pops into my mind is like, what is the main advantage for a developer who maybe develops in C# or C++ to ship his application to the web? So why should I care about the web browser in the first place?
I think the most obvious answer is that this is truly cross-platform, and that does not only refer to desktop and mobile systems, but basically to anything that is capable of running a browser. So you write it exactly once, and you can reuse that code base on a super huge user base, right? So all desktop operating systems which use the right browser, all mobile operating systems, and also the browser itself, because you don't even need to install it. Also, there's never login. So if you are at the position where there's an API that you need because the application will not run, you can still switch to wrapper solutions like Electron or Capacitor provided by Ionic and ship it as a native application. And so basically your investments into a web-based application should always pay off.
I see. Okay, you say I have to write it once and it runs everywhere, but we have different kind of browsers, right? And you showed us this table, and there were a lot of difference, like this kind of web API is just available on Chrome or maybe just on Edge or on Chrome and not on Android or on Safari. So how does this fit in then when you tell us just write it once?
That's why this progressive enhancement is so important. Always test for the existence of the API. If it exists, use it. And if it doesn't exist, use a fallback mechanism. If you use Paint, for example, on your mobile operating system, it will appear to function the exact same. Even though, and also in Firefox, for example, the majority of stuff will work. And that's because there are sufficient fallback approaches. For example, if you don't have access to the clipboard, you can just keep a local copy. Then you can, for example, duplicate a part of the drawing, but not share it to another application. But at least there's something. And that's always the idea. Provide a good fallback mechanism to the user so that they can at least do a little bit of what they try to do. Also important to note is that Apple has recently implemented many, or at least some, of the Fugu APIs. But yes, what's also true is that Firefox typically does not implement the APIs here that we've seen here. They've become quite slow in implementing stuff like that.
I see. So let me add another question regarding this web APIs. I'm working on a project and we wanted to have a little spike about the file system access API. And a lot of clients are really scared that Chrome, they have a feeling, and I was wondering why they have this feeling, that Chrome might remove this API really fastly again because of security issues. And what is your experience of the stability, let's call it like that, of being shipped in the Chrome and staying there actually for a long time?
So there's a huge process before an API is actually shipped in the browser. It's super long. So for example, the security teams from Google and Microsoft, maybe depends on the API, have a look at the API. They need to pass a review by the technical architecture group of the W3C. There's a specification that is being created within the YCG, the Web Platform Incubator Community Group at W3C. So an API has to pass so many stages and then there's a developer trial and an origin trial before it finally ships. There's a shipping process in Chrome and stuff. So there's so many stages that need to be passed that it's quite unlikely, I would say, that an API is being removed later on because they totally missed something. All these APIs are discussed and implemented in the open. So I guess if there were any severe issues, it would be very transparent to make them obvious. Yeah.
I see. Makes sense. So let me jump to the questions from the chat. So Michael asked, he asked it in German, so let me translate it to English as well. So if you create a progressive web app and you have it as a native web app kind of on your desktop application, is it possible to mark it as your default app to open specific kind of file type?
No. It's a nice idea, of course, or at least maybe. It's a nice idea, but I guess every application would like to be the default. So essentially all applications would set it to the default handler. It can get a default if no other application has registered for it yet. Then it will be the default, but as shown that PNG file, or with that PNG file, the default will stay. But if you have a proprietary file extension or file type that you register for, then you will be the default application. Yeah.
I see. So I am pretty sure I pronounced it wrongly, but Yusuf asked another question. Do you think PWAs can be used for an offline and multi-device real-time when online use cases?
Okay, that's a tough question now because I don't know what when online it should be real-time. Depends on what real-time exactly means here. The general answer I would say is yes, because PWAs can perfectly work offline with the data that they have at this point, and because they are obviously offline. And when online, they can of course connect to whatever server in the background and fetch data from them. So I would say yes, but if you have more details, you can also send me a DM on Twitter, for example, right, or drop me an email, and then we can discuss that maybe.
Great, thank you so much. I have another question, or maybe like a closing sentence. We have PWAs, and now there's Project Fugu. And I guess a lot of person mixing this up and they don't know the line or don't know when you just call it PWA or when it is like part of Project Fugu. Can you maybe clear it up, or can you, as far as I understood, it's like, of course you have application, you can create a PWA out of it, so you have it like as a web app, or a native web app on your smartphone. And Project Fugu helps you to access native APIs, more or less like an extension, maybe even to PWA. Or
Absolutely.
how would you explain it? Yeah.
I would say Project Fugu makes PWAs better in general, but PWAs are here to stay. So Project Fugu doesn't replace it, but offers or brings new capabilities to the web as a platform. PWAs stay as they are, and also many of the APIs that I've shown you will continue to work without installing the application. So for example, async Clipboard API and File System Access API also work without ever installing this application. So basically it's just an add-on, so to say.
I see. That's super cool. So thank you so much, Christian. I
welcome.
shared your Twitter account on a banner so they can follow you. And of course, if there's an add-on question, Yusuf, you can just send him a DM. I guess his DMs are always open and he's always glad to help. So thank you so much, Christian. It was really interesting. And we will have a short break right now for about 15 minutes. And after this break, we will have Rainer talking about Rust and WebAssembly. So grab yourself a beer, a coffee, or whatever, hang out in the chat and ask questions to each other. And of course, find yourself comfortable, and we will meet each other in 15 minutes again. So thank you.
back, everybody. First of all, thanks, Christian, for this amazing talk. Next up is Rainer Stropek with Rust and WebAssembly. So everybody, please give us a few clapping hands into the chat. And the word goes to Rainer. Thank you very much.
Thank you very much. Thank you for the nice introduction, and thank you for having me here at KarlsruheJS. I'm really glad to be here. I was invited to talk a little bit about Rust and JavaScript, Rust and WebAssembly, how these two things go together. And I'm looking forward to 30 minutes of Rust, WebAssembly, and TypeScript. I promised you that this will be a talk for everybody, including those of you who do not know Rust so far. So if you are a Rust beginner and you are just curious how this language feels, you will get a glimpse of Rust in this talk. So it's not just about WebAssembly and TypeScript. Second, I promised you a talk without any slides. I promised that I will do code only, and this is exactly what we are going to do. For this talk, I created a brand new sample, and what could that sample be about currently? It has to be about something in the Wordle, Nerdle, Mathler universe. Yes, we are going to do a puzzle, a number guessing or formula expression guessing puzzle similar to Mathler or Nerdle or things like that. And I'm pretty sure that many of you know the principle. Let me quickly show you what this is all about. And thank you for bringing my screen up. Here you see how this Nerdle thing will look like. Nerdle works in this way, or it's more Mathler. Maybe you have ever played this game. Have you ever played? If not, try it. It's a lot of fun. You get a result, as you can see it here, and then you have to guess a mathematical formula that results in this number. And then you will get some color indicators. Black means this number or operator doesn't appear in your formula. Yellow means this appears in the resulting formula, but on a different space. Green means that this is the correct number or correct operator at the correct space. And this is exactly what we are going to do. Now, it would be easy to implement that in TypeScript, of course, but the sweet spot of Rust and WebAssembly comes in where it comes to number crunching. And in my case, I am simulating this problem space by distributing the work in the following way. In Rust, in WebAssembly, we are going to generate the expression that the user has to guess. So this is a little bit of number crunching, not very complicated, but I only have 30 minutes. So it is an example, granted, but still it is a little bit complicated business logic. So we have to do some loops and conditions and things like that. And the user interface, this is the domain of TypeScript and the browser. And this is where TypeScript comes in. And I'm going to show you how we will consume the Rust code inside of TypeScript. This is exactly what we are going to build. Now, if you would like to follow along, or if you would like to try the example at home and dive deeper into some of the things that I'm going to show you, the whole code is online. I already posted the URL, and I think it's currently, you see it currently in YouTube. The code is online. I created a bit.ly link for you, and here you also see the link. Here it is. It's on GitHub. Just go there, and here I have my script for today's talk. It's written in a kind of hands-on lab style, so you just have to follow step by step by step, and then you can recreate the entire sample that I created for this meetup today. Okay. Without any further ado, let's get right into the topic and let's get right started. The first thing, we have to set up a new project. And in Rust, you have a neat little tool, which is called Cargo. Cargo is like NPM for TypeScript and JavaScript, but for Rust. And with that, we are creating a new project. Cargo new Nerdle, I called it Nerdle, and it's type of library. If you want to build a WebAssembly thing that you can consume from JavaScript or TypeScript, you have to create a Rust library. And this is what we did. Let me go into that folder and spin up Visual Studio Code. It opened on the wrong monitor, and now it's on the correct monitor. And don't worry, I will zoom in so that you will see the code that I'm going to write. Now, let me quickly tell you a little bit about this project. This is a typical Rust project. I zoom in a little bit. The cargo.toml file it is similar to what you know from package JSON. It contains the dependencies, some metadata, and so on. The cargo log file is like the package log JSON file. Git ignore, I don't have to talk about that. Source is where our source code lives, and target it is what you might know as JavaScript developers as dist. Yeah, in Rust, it's called target. So the first thing that we are going to do, we are going to set up, as you can see here, we are going to set up our dependencies. And unfortunately, I really have very limited time today, so I will just copy in all the dependencies that we are going to need in one go, and I will only show you some of the things that are really important here. This is the metadata, just like package JSON, but this is not JSON. This is Tom's obvious markup language, TOML, and yeah, it is like it is. We are creating a library. This is relevant and necessary for creating a WebAssembly library. And here we have the dependencies. And the most important dependency is this one. Please remember it, WASM bind gen, because this is where the binding generator lives. The binding generator, which creates bindings from Rust to WebAssembly and then also to JavaScript and TypeScript. So this is the magic tool. This is Harry Potter. This is the fairy dust that we spread across, that is sprinkled across our Rust code, and it will generate WebAssembly and all the necessary JavaScript and TypeScript helper code that you will see in a second. What else do we have here? This one is nice because then we get so-called panics, exceptions in Rust directly in the browser's console. It's just a helper thingy here. SERDI stands for serialization and deserialization. It's the serializer and deserializer from Rust. Rand and getRandom are just random number generators. And in this case, we are using a random number generator that can reuse the random number generator that is built in the browser. Last but not least, we have some def dependencies that we are going to use within our unit tests. Yes, you heard correctly. We are going to implement unit tests for our Nerdle, and we will run the unit tests in WebAssembly outside of the browser. So you see everything in Node.js. So we will write unit tests and run them in Node, and they will make sure that our code really works. And the last one, you will see it later on. It's similar to what you know in JavaScript as eval. Yeah, it's the thing where you throw in an expression and it will calculate the result. This is a helper library that we will just use for the purpose of testing. So this is just the testing stuff. This is cargo lock in a nutshell, if you want. And with that, we are perfectly fine, and we can go directly into the source code. Here we have the source code, and currently the source code only consists of some tests, and we are going to delete that immediately. So let's set up the first lines of Rust code, okay? So let me open it here on my right-hand monitor, and I'm going to copy in some code, and this will just be some setup code which is necessary. So what you see here is some so-called use statements. They are just like import statements in TypeScript or requires in JavaScript. Very similar. This is just the syntax as it is in Rust. Don't worry about the warnings here. They are just telling us that we are currently not using all these use statements, so the warnings will go away once we finish our sample application. The next thing jumps directly into our main topic, because this is really interesting. As you can see here, we have our log function, and guess what? This is the console.log. This is an external function, and WASM bindgen is capable of making all the JavaScript goodness available from Rust. So whatever you implement in JavaScript, if you have any JavaScript global method, you can directly import it here. It can be a built-in function like console log or alert, but it can also be a custom function that you wrote. So the direction call a JavaScript method from Rust works perfectly fine, and this is exactly how you do it. Not very complicated. For those of you who are new to Rust, you might wonder what this here is. Let's use a different color here. This is a macro. This is a macro. If you have ever written C or C++ code, you might have nightmares from macros, but believe me, this is not your grandparents' C macros. This is a brand new way of macros. In Rust, macros are really huge. You use them all over and over. They are there to make your life easier. Rust is not the easiest thing on earth, but macros make the complexity go away. It's just, as I said, some Harry Potter programming, a little bit of fairy dust, and everything else will be generated out of the box. Macros are a huge thing in Rust. You can take that away from this talk. Okay, nice. So we have the external dependencies, and we can fold up this code region to focus on what we are really going to do. The next thing is we need an initialization function just to get started. Yeah, we are just warming up. Okay, I want to show you some warm-up stuff. Now this one is a function, as you can see it here, and again we have WASM bindgen macro on top of it. So this is the way how you can make a Rust function callable from JavaScript or TypeScript. So whenever you decorate something with the WASM bindgen macro, then WASM bindgen will generate the necessary WebAssembly binding JavaScript code and TypeScript code to make this function easily available from JavaScript and TypeScript. And in this case, we are setting or initializing the console arrow panic hook to make sure that any kind of panic unhandled exception is displayed properly in the browser's console. If you really want to shrink down your WebAssembly to the absolute minimum, of course, you are going to avoid panicking at all because that is code at the end of the day. But this is a sample environment, and it really doesn't matter if our WebAssembly is, I don't know, 20 kilobytes or 18 kilobytes. It really doesn't matter. So I put it in, make it nice. And here you see now everything coming together because this function will be called by JavaScript. And with this function, we will call back into console log and display something in the browser log. So this is where JavaScript comes in, and this is where we call back to JavaScript. And in this case, we are going to take a string, as you can see it here, inclusive UTF-8 characters, emojis. Every talk needs emojis, right? And we are going to print something on the screen, okay? And this is the first things that I wanted to show to you. Okay, nice. Let's fold up this region and we can get started a little bit more. I am going to copy in some additional code, and this is especially interesting for those of you who have never seen Rust before, because you are going to see some interesting things about Rust. First, let me zoom in here a little bit. What you see here first is a so-called enum. You might know enums from other languages like TypeScript or C# and things like that. And you might think that you know enums, but believe me, enums in Rust are completely different beasts. Enums are similar to structs, but they are even more powerful than structs. In 30 minutes, I cannot go into all the details. I cannot give you a full overview, but just trust me with this. You will see a little bit that in the upcoming minutes. But enums are a whole universe on their own, and we could talk for hours about them. It's not the enums that you know from TypeScript. We are not going to talk about the derive macro up here. It just auto-implements code with which we can copy and clone an operator. In this case, the operator is just a byte indicating the operator that we generate in our code puzzle. But the next lines of code, if you take a look at that one, for instance, then you already get an idea how powerful enums are, because this is again an enum, but now we can implement a so-called trait. A trait is similar to an interface in TypeScript, but way more powerful. So interfaces know a little bit and traits know way more. Again, we can talk for days about how traits work. Traits are essentially what make Rust an object-oriented language. You have polymorphism, you have monomorphization, and things like that. A lot of stuff. You can have dynamic method dispatching, you can have static method dispatching, you can have generics, and many, many other things. And here we are implementing a so-called system trait display for our enum. The system trait display is used whenever we want to turn an operator into an end-user friendly string representation. So in this case, we are using a so-called match statement, and this match statement turns our operators into characters. And this is exactly what we do here. We are turning our internal enum into an end-user friendly string representation. But the point is, we have an enum and we implement an interface trait in Rust lingo we implement a trait for this enum. This is pretty powerful, and you probably can't do that in a lot of languages because enums are completely separate from classes or structs. But in Rust, that's perfectly fine. And in the same ballpark is this thing here, implement operator. Here we can add functions to enums. So in this case, I add 3 functions. The first one is muldiv. Is it multiplication or division? It's pretty simple. It uses pattern matching here. Self indicates that this is an instance method. So you need an operator in order to call this method. It's not a static member. It's an instance member. This is the second method. It's pretty obvious, isn't it? And the third one is, again, very interesting, and we have to take a little bit of a look here. The third one is a calculate method. Calculate means that we take the given operator stored in self. We have a left operand, we have a right operand, and then we calculate the result by either doing the multiplication, the addition, and the subtraction. And the division is a little bit more complicated because in our game we have a rule. And this rule says whenever we do a division inside of the expression, it must not have a remainder different from 0. So we can't add 5 divided by 3. That is not possible because 5 cannot be divided by 3 without a remainder. We can have 6 divided by 3 because 6 divided by 3 is 2 with no remainder. Get the idea? This is the business logic that we do here. And the reason why I did that like that is this one. This is the star of the show here, result. This is how you indicate the result, an error or success in Rust. In JavaScript, you would probably return either a Boolean if you have a method like try something, or you would throw an exception. Exceptions do not exist in Rust. It is not a good practice to return a Boolean. The good practice is to return a result. And result, guess what? It's an enum again. An enum with 2 possibilities. Either OK, then we can pass in a result, or error, and then we can optionally add additional error information here. I will not go into that details because I only have 30 minutes. So in this case, we are just indicating there was an error. Okay? This is what we do here. And guess what? If we call this method from JavaScript, then the WASM bindgen will auto-generate JavaScript code which understands result, and if result results in error, then it will automatically throw an exception in JavaScript. So the WASM bindgen infrastructure does not just stupidly allow us to call, but it also understands the most basic principles of the languages, and it can translate these things. Result is translated into an exception. There is another very famous enum, which is called option. Can be either none, it's like null, or undefined in JavaScript, and some, which is really a value. It's Rust's representation of a null pointer. And guess what? If you return option, then in TypeScript, you will get an optional data type. And it will be automatically translated into null or undefined. I think you get the idea. Okay? These are these methods. Good. I like that. Everything is okay. And we can start the next topic. The next topic, now we have written a little bit of code, is obviously some testing. Because hey, we are good developers, and therefore, if we write non-trivial business logic, we are going to write some tests. And this is how you write tests. As you can see it here, you can put the tests directly into the same Rust file, as you can see it here, or you can also put them in separate files if you want. You can also create a separate folder, which is called test. As a sibling to source, you can call test, and in this tests folder you have some integration tests, for instance. So it's up to you if you want to have it inside of the file, in a separate file, or even in a separate folder, depending on your needs. And in this case, I'm testing the display functionality by, as you can see it here, formatting the plus operator and checking with assert equal whether the result is a plus. The exclamation mark here indicates again a macro. Assert equal is in reality a macro again. Now this tries to do a correct calculation. 1 plus 2 is 3 with an OK. 4 divided by 2 is an OK of 2. But if we try to divide 5 by 2, it would result in a result with a remainder, and therefore it has to be an error. So these are tests that we did so far. Okay, so I think it is now time to give it a try and test it. Let's do that. We can use WASM Pack. This is the tooling. It sits on top of Cargo, and it does everything we need for working with WebAssembly. And in this case, we are going to test, and we are going to run the test in Node. You could also run your tests inside of the browser, but I don't have the time to go into the details, but I'm pretty sure you will find out the details by just Googling it. So let me run this guy here. As you can see, everything is compiled. It takes a while because we just created this application, and the next time we call this thing, everything is okay. We still have some warnings because we don't use some of the things, but the important thing is here. As you can see here, we compiled our Rust code to WebAssembly. Then we spun up Node.js. In Node.js, automatically our WebAssembly has been loaded and our unit tests were executed. And as you can see, 3 passed. In order to show you that this really worked, I will mess it up here and I will rerun my tests, and obviously it will not work. As you can see here, OK2, OK3 doesn't work as expected. So it isn't a fake, it's really doing what I promised to you. Okay, nice. Now we have the operator logic. It worked as expected, so we can fold this one up. Fold up the tests. We will come to them later on, and I will again copy in a little bit of code. This will be the last section of code that I'm going to copy in, and afterwards we are going to take a look at a little bit of TypeScript. Now let me grab this code. Here it is. There it is. And this code is now generating. Oh, I forgot to copy a little bit above. Give me a second. Bear with me. And here we are. Now we are good. Now, this code is really the heart of the algorithm because it's generating the puzzle. First, we need a data structure. Please note that we have the data structure challenge here, and it's serializable and deserializable. There is a multitude of options how you can communicate between JavaScript and Rust. You can JSON serialize things. You can directly access objects in Rust memory from JavaScript. You can directly access JavaScript objects from Rust. You can have shared memory arrays, unsigned 16, unsigned 32, or float arrays where you can read and write from JavaScript and read and write from Rust. You can have a lot of different possibilities. I only have 30 minutes, and at the end, I will give you some additional links that you can use to dive into the topic of different variants of parameter passing if you want. But I think you get the idea just by looking at the code, right? It's the calculated formula in string representation and the calculated result, which is an integer value. Now, the code itself, I will not go into the details. I will just pick out some very special things. This is, for instance, an array, as you can see it here in Rust. Arrays are completely different from what you know from JavaScript arrays. Arrays must have a compile time fixed length, and it cannot change. This is what arrays are. If you want to have something similar to a JavaScript array, you would use a vector, the data type vec. Okay, the data type vec. This would come close to what you know from a JavaScript array. It's not the same, but you can push things into it and you can access with index and things like that. Now you see some interesting control constructs here. You see a for loop, for instance. Another thing that I can point out in Rust, all the variables are by default immutable, deeply immutable. If you want to have a variable to be mutable, then you have to explicitly say this variable must be mutable. Otherwise, you cannot assign a different value to it. What else do we have? Well, here we have a random number generator. This is a range. You might know that from other programming languages. What else do we have here? Let me see. You have, again, this match statement, which is kind of interesting. You can use some pattern magic here. This is a format string. In TypeScript, this would be the backtick with a $sign in it. You probably know that. There is a multitude of options how you can add and reference the parameters that you want to do here. So in this case, I'm just using some number, then an operator. A number, an operator, a number, an operator. I think you get the idea. Yeah. Then we check the length. The length must always be 7, so pretty simple here. But now comes something which is pretty powerful. Okay. So here you can see I created a function inside a function. This is a nested function. Absolutely no problem. Works perfectly fine. But the magic here is that here we are calling the calculate method from the operator that I showed you before. And if you remember back what we did here, the operator calculate can return either OK with a result, but it can also return an error if we have a division with a remainder. Can you remember? This is what we have to deal here with. And the beautiful thing in Rust is that if you call such a method, you can see it here, you can simply append a question mark. This question mark will recognize if the calculate method returned an error, and it will automatically propagate this error to the caller of this calculate method. So we do not need an if statement here. This is called error propagation, and it comes in super handy. Once you are used to it, you really don't want to give it away anytime soon. So this is really powerful. Okay, this is I don't want to go into the details how I do the calculation. If you are interested in it, it works. You can dive in it. We just want to take a glimpse of code into Rust. Okay. Now, what else do we have? Here we are just checking. This might be an interesting one. This is the idiomatic way of checking whether the result, which is a number, is between 0 and inclusive 99. What you essentially do is you are setting up a range, you call the contains method, and then you pass in a so-called borrowed reference to the result. This looks a pretty complicated way of checking whether a number is between 0 and 100 excluding or 99 including. Okay, so the beautiful thing of Rust here is if you use some things like iterator, and technically this is an iterator because what we get back here is an iterator, and we are using a method on top of an iterator to verify whether the number is in the numbers 0, 1, 2, 3, 4, 5, 6, 7, 9. This is the mental model what we are doing here. But in Rust, we have a very important motto, and this motto is zero cost abstractions. Although you are using conceptually an iterator, also if you do things like sum or map or filter, things you know from JavaScript, even if you do things like that, Rust will not give you the performance overhead. It will recognize these things and it will optimize it down to the most optimal assembler, in this case WebAssembly code. So this will result in very optimized comparisons. This will not do at runtime any kind of iterator magic or maybe even some vtable calls and things like that. That's the idea of Rust. You express your application with very powerful abstractions, with iterators, with error propagation, with enums, with structs, with trait, but you do not pay for these abstractions at runtime because Rust will optimize away a lot of these things. And then comes in LLVM, the low-level virtual machine, and it will do additional optimizations on top of it. And then you will get really, really powerful code. Code that is as fast as C, and in many cases faster than C++. And definitely faster when it comes to number crunching than JavaScript, C#, Java, or whatever you want. And at the end, we take this data structure that we did, and we are using the serializer and deserializer to directly write that into an object in JavaScript world. Okay, this is what we are going to do here. Finally, I have written a unit test for that. Of course, as good developer citizens, we have to use a unit test for that. You see the test. And in this case, I'm just generating some challenges, and I verify the business rules. Length must be 7, result must be between 0 and 100, and the result must be the same as the evaluated formula. Here I'm using a third-party tool which is capable of evaluating strings. It's like the JavaScript eval functions. We pulled it in here, but please note that this is just a def dependency. So we do not pay the price for this dependency at runtime. This is just for testing. And I do that 100 times. So I generate 100 formulas and check whether they are correct, because we have a little bit of randomness in here. So it makes sense to do it often. Let's try it. And as you can see, we do not have any warnings anymore. We ran 4 tests. Everything is okay. 4 passed. So the Rust code is done. We now have a Nerdle implementation of generating the puzzle. Now you'll wonder, okay, how can I consume that in TypeScript? And I only have, let's say, 5 minutes left or so, so it can't be complicated. It isn't. Let me show you that. So let's compile everything, WASM pack build. And what we get, once the build is done, take only a few moments, it compiles everything. Come on. Compiling to WebAssembly, by the way. The first time takes a while. Yeah. This is live, so this is not prepared. I can show you that again. If I run it again, it's pretty fast, as you can see. And now comes the interesting thing, because what we get when we compile this one with WASM pack is that we are getting, at the end of the day, an NPM package, just an NPM package. And this NPM package, you can publish it on NPM if you want, but you can also reference the folder if you want. So here you see the WebAssembly file. You have some, as you can see it here, some helper code. This is some glue code, which makes it super, super easy to communicate with Rust. This is where code is generated for handling Rust's result and turning it into exceptions, or where the serialization and deserialization from Rust world into JavaScript objects happen. And these things are inside of this JavaScript code. It's auto-generated. You don't have to care for it. And what you additionally get is you get, as you can see here, the TypeScript type definitions. See it? You have the run method, we generated it, and the generate challenge method. That is also the one that we generated. So you get TypeScript type definitions, you get JavaScript that makes it simple to call, and you get a ready to consume NPM package. Now let's try it. I will not go into the details of the TypeScript code, because you all are probably TypeScript experts. Probably you are even better than I am, so I don't want to embarrass myself. By the way, big kudos for the TypeScript code and the CSS magic and all these things to Karin Huber, from my wife, and a mentor of the Coder Dojo Linz, programming club for kids. And she prepared this example for programming with some junior coders for the Coder Dojo, and I sneaked in and took her CSS to make my result look beautiful. So I didn't invent the CSS. That's really up to her, and thank you very much here. I only added the Rust stuff here. So let me show you what we do here. The most important thing is this one. See? Here we have a dependency, a runtime dependency, onto the package folder. Here we have the package folder. This was generated by Rust by WASM pack. This is what we generated from our Rust code. Then we have a little bit of Webpack magic with TypeScript. You all know that. You can take a look in my sample code. And then I can take a look here, for instance, at index.ts. And this is how simple it is to call a method from Rust. Let me call in the www folder npm install in order to get all the different dependencies. So then this red squiggly stuff will go away. Let's open the board, I think it is. Let me see. Is it here? Is it here? Is it here? No, it's in the game. Sorry. Yes. Here you see, oops. Let's do it this way. Here you see, this is the call to Rust. See? This calls our method, and this method returns an object containing the formula and the result. Can you remember this one? This is exactly what we had here. See? So the Rust data structure reflects here in our game. This is the challenge. Okay, good. Let it run. npm start. This will spin up the Webpack dev server. So let's go here. Boom. And this is on our, see it here. And yes, I am cheating. Yeah. Here you see first, this is the result of our run method. And yes, I'm cheating because I'm printing the final result here. But I think you get the idea. Let's make it wrong first, okay? So let's write 98 plus 6 minus 87. Press enter. And as you can see, we are pretty good. We already guessed 5 elements and 2 are wrong. So now let's make it correct. So this is 98. I can also use the keyboard plus 5 minus 86 and then press enter. And you see, yippee, we managed to do it. So the whole UI stuff, it's consciously very, very simple JavaScript. No framework, no Angular, no Vue. It's vanilla JS, nothing fancy. But the number crunching is completely done within Rust. And we call into Rust to generate the formula, the expression, and to calculate the result. We have unit tests for Rust running in Node.js, and then we have a beautiful UI just sitting on top of it, doing what JavaScript really makes best, and that is UI stuff, not number crunching. That's essentially what I wanted to show you. And if I take a look at the watch, I think I used 6 minutes more than we agreed on. We agreed on 30 minutes. I hope that is okay. And now we can take a few questions if you want. Martina.
Yeah, thank you so much for your presentation. I actually always love when it's more live coding than just like a huge slideshow. And actually, I do have a question as well. Or actually, I'm pretty impressed as well, since you know I am actually like running C++ in WebAssembly, and I'm always wondering why everyone is jumping so much on Rust to WebAssembly, and no one actually cares about C++ to WebAssembly. And actually, a question I always get asked, and maybe you can answer it as well, is why WebAssembly at the first place? So why should I ship my Rust application to the web? Yep. Why should I care about that? And of course, does Rust shipping to WebAssembly and to the web browser finally replace JavaScript? These are always 2 questions I got asked as well. So I want to hear your answer to that.
I can give you my 2 cents on both. The first one, why should I care for WebAssembly? Now, first, you have to understand, or everybody has to understand, that WebAssembly is not just about the browser. WebAssembly, it's neither assembler code, nor is it code in the browser, so in the web browser. That's not WebAssembly. WebAssembly means that you get non-trusted or semi-trusted code from the web, and you want to execute it securely and efficiently on your machine without having to be afraid of security issues. If you have code in C or C++, and you download this code from the internet, you have to trust the developer that they don't misuse their power, because they can do whatever they want when you run their C or C++ code. But if I compile my Rust code to WebAssembly, and you take the WebAssembly and run it, for instance, inside the browser, or in Deno, or in Node.js, inside the WebAssembly runtime, you're running the code essentially with assembler speed, but inside of a sandbox. So the code cannot do harm to your computer, because if we run it in the browser, it's protected by the browser. If you run it outside of the browser, it's protected by the WebAssembly runtime, which is embedded, for instance, in Node. So this is essentially it. You get the performance of assembler. You get the possibility to compile anything down to WebAssembly, not just JavaScript. So you get additional languages. And you can safely ship this code to any device. Can be a server, So you run WebAssembly on the server to execute some code there. Or on a desktop PC, maybe we will see some native WebAssembly apps that you can just double click in Windows and it will magically execute. And you can also do it inside the browser. So this is the first answer why, as a Rust developer or C developer or C++ developer, you should really care for WebAssembly. It gives your customers control and security. And the second question, will Rust replace JavaScript? No, absolutely not. What WebAssembly did is it broke the monopoly of JavaScript in the browser. This is what WebAssembly definitely did. So in the past, if you wanted to write code for the browser, you had to do it in JavaScript. Granted, you can use a cross-compiler, some kind of transpiler that compiles TypeScript into JavaScript or C into JavaScript, ASM.js. Can you remember the times that we had it? You can do that, but at the end of the day, it always came down to JavaScript. And with WebAssembly, that's no longer the case. Whatever you have, if you can compile it down to WebAssembly, it will run in the browser. So you have the choice to combine things. But the WebAssembly standard is pretty limited inside of the browser. For instance, as of today, you cannot directly access the DOM. You cannot directly make a web request. So WebAssembly can just manipulate bits and bytes in memory. And then you need JavaScript in order to communicate with the outside world, to manipulate the DOM, to send something over the wire and things like that. Will that change? Well, it's already changing more and more. And will we have WebAssembly only apps at some point in the future? Definitely. I'm strong believing that. So there will be a life without JavaScript if you want it, but you don't need to. If you like JavaScript and you just want something like Rust for compute intensive stuff, hey, feel free to mix them. Better together, not replacing. That's the message that I want to bring across.
Absolutely. Yeah, that's also my opinion. Thank you so much. We have actually 2 questions from Julian in the chat. The first one is, here you focused mostly on the collaboration of Rust and JavaScript, but what top use cases do you see for Rust?
2 things. First, if you have an investment in Rust, for instance, if you build some medical software and you invested a lot in Rust for some visualizations of maybe X-ray data or whatever you want, then it makes absolute sense to take this existing code or existing code fragments if you additionally want to add a browser frontend. We already heard about the use case in the first talk where Adobe is using parts of their code base in order to bring parts of Photoshop into the browser. It's not a question of whether they are not wanting to run it in JavaScript. It's simply existing code. So for all the companies that are, as of today, investing a lot in Rust, and believe me, a lot of companies are doing that, it's a way of reusing existing code and still bringing this code into the browser. That's the first reason why you should care for Rust. If you don't have an existing investment in Rust and you ask yourself, should I do it? Well, the answer is it depends. If you just want to do web development and your applications are mainly web requests, data binding, DOM manipulation, and that's it, you probably don't need Rust. It's not a big thing. Stay with TypeScript, stay with JavaScript, it's perfectly fine. However, if you want to do some really heavy calculation stuff, maybe some crypto stuff, maybe some rendering stuff, maybe some game or visualization stuff, maybe some physical or mathematical calculations, then WebAssembly is simply faster than JavaScript. But do test. It's not given that WebAssembly is always faster than JavaScript. If you have a lot of jumping around between JavaScript and WebAssembly, you might lose so much time for this communication thing that at the end, you are slower than just writing JavaScript. So you really have to test it. But in general, if you have to do a lot of calculation on the client side, then WebAssembly typically shines.
Absolutely. And I like to second that in a sense that with WebAssembly, you even have the possibility to use all the other third-party libraries from all other languages that can be compiled to WebAssembly.
Absolutely.
So for instance, C++ is really has a lot of like 3D rendering image recognition libraries, and you can just port them to WebAssembly and use them because there might be no such NPM package out there in the JavaScript ecosystem. So you can take advantage from all the other ecosystems around all the other languages. So this is also a great advantage.
Absolutely. Can I add something here? In the recent versions of Blazor, for instance, that's Microsoft's implementation of WebAssembly from .NET. So if you want to write web applications in C# and .NET, you can do that, and they compile it down to WebAssembly. They, for instance, added interoperability between C# WebAssembly and other languages like Rust. So what you can now build as of today, you can build an application easily that consists of C# things, a little bit of Rust things, and a little bit of JavaScript, HTML, CSS, and so on. You might think, well, that's Frankenstein, right? Nobody wants to do that. But believe me, yes, a lot of people want to do that. They have an existing investment in C# that they cannot throw away. They maybe want to add the compute-heavy stuff in the future in Rust. And they also have an existing investment in JavaScript because they maybe took a look at Angular or Vue or whatever, and now they simply cannot afford to rewrite everything in a single language. So they have to, at least over a certain period of time, go through a transition where it is super important to be able to connect things, and WebAssembly is able to do that. It's able to bring together pretty different programming environments in a single environment. It's maybe not the most efficient execution if you mix and match things like that, but sometimes you simply have to go for it in order to do a transition over multiple months or years.
That's super interesting. I didn't know that about Blazor yet. It sounds scary, but also really powerful, I guess, on the other side. Great. So Julian has actually another question. I guess you answered it already a bit, but let me read it to you. Could you name 2 major advantages Rust has from your point of view as opposed to other programming languages?
Only 2?
The result, of course.
Can I have 20? Okay, the 2 most important ones. The first one is obvious. Believe it or not, Rust doesn't have a garbage collector. Again, Rust doesn't have a garbage collector, but still you write memory safe applications which are more memory safe than most managed languages. And that's the magic sauce of Rust. This is why Rust has become so popular. It's super fast because it can produce safe, mathematically proven safe code, which does not have memory leaks, which does not have use after free problems, which does not have double free problems. Martina, you know this from C, C++, and so on. That's really an issue in that area. So memory safety without a garbage collector, this is number 1 if you ask me about Rust. The second thing that I love about Rust is the power of the language, the expressiveness of the language. If you dive deeper into Rust, you find so many gold nuggets inside of the language. I just showed you a little glimpse of it. You have seen traits today. You have seen error propagation today. You have seen pattern matching and the match statement today. We could talk for hours about these things. Macros, they are essentially a way of meta programming. So you can build a domain-specific language with Rust macros that you can use inside of your Rust programs. Oh, this was already the third one, and I could go on and on and on. So this was just a few of them. So Rust is really a very interesting language, if you ask me, just from a language point of view, definitely.
Yeah, that's quite funny, actually. So my boyfriend right now, he's starting a new work, and he's learning right now Rust, and he coming from a C# background, and like it's every hour he jumps at me, oh my gosh, I learned something great at Rust. It's so much better than C++ and C#. So look at it, this is so cool. Here you have this result and the error handling, it's so crazy. And it's kind of drives me crazy, but it is definitely a really, really interesting language.
Yes, it is. Yes, it is.
So,
I really enjoy it very much.
So thank you so much, Rainer. Actually, you brought us another conference. Maybe you like to have a few words about the
Absolutely.
Global Azure
I would
Day.
like to invite you to 2 events. First, the globalazure.at. Global Azure is for all of you who are interested in cloud computing, in particular Microsoft Azure. It will be on May 6th. It will be a virtual conference. It's completely community driven. It's completely for the community. It's for free for everybody. We already have a pretty astonishing lineup of speakers. So check out the website. And if you have time and if you find something interesting, we would love to welcome you there. That's the first thing. And the second thing, I am one of the co-founders of the Rust Links meetup. So we do a monthly virtual, thank you very much, Martina. We do a monthly virtual meetup. Also, of course, for free, all about Rust. Every month we have some guest speakers or maybe local speakers. We are very beginner friendly. So even if you are learning Rust and you want to get some new ideas or pointers to some great crates or packages, then this is exactly what might be interesting for you. So both things are community driven. They are for free. So if you want to take a look, we would love to see you there.
Yes, thank you so much. It's always great to have you. Actually, you're a really great speaker and really enthusiastic and passionate about your topic. And it's really, really lovely to hear you talking.
Thank you.
So thank you very much for being here. If you still have any kind of question, thank you. If you have any kind of question, reach out. I posted his Twitter handle over there. I guess his DMs is always open for any kind of question, and meet him at the Linz meetup. And thank you so much, Rainer, for being here. So give him a warm applause on the chat, and hope I see you soon again, Rainer. Bye-bye.
Thank you very much. Thank you for having me.
So I also like to give a short shout out to a conference that I'm organizing with a great team. It's the German Angular conference. It takes place in Berlin in September. There's also the CFP open right now. So you can just go at the link I'm just sharing right now and just submit anything about Angular, anything TypeScript related. So feel free. And if you have a great topic to talk about, just go ahead and submit a talk. It's in person, and we are pretty sure that it will take place in person as well. And for all of you who stayed till the end and who wants to go to this conference, we share a discount code. So just grab your code right now, and if you want, you can just have a 20% discount off the ticket. So feel free, either go there on the conference, buy a ticket with our discount code, or submit a talk. And with that, I will give the last words to Karl, and he will share the closing notes for today's meetup.
Yeah, so thank you very much, Martina, for organizing all of this, and of course to the speakers, Christian and Rainer. 2 really great talks, 2 great speakers. So really happy to be able to host them today. And to the community, thanks everybody for watching. If you're watching this live or after the fact. And like I said, please, if you want to give a talk or if you want to help us organizing this, reach out to mail@KarlsruheJS.org as the email address, or via Twitter at KarlsruheJS. And that's it for today. Thank you very much, everybody. And I don't know how we're going to do the hangout after the meetup. We could just do it in the Discord chat, because I think, maybe you can share the link to the Discord. It's right there. Perfect. So that's where we hang out in between events. And maybe you can share, what you thought about the talks, or if you have any questions for the speakers or us or whatever. All right. Thanks, everybody.
Bye-bye.